Okay, here we are, section 13.2, second half, the integrals of vector functions. This is sample number 13, and this actually turns out to be the first problem where we're applying an integral. As I told you in the lesson, not a lot of applications for integrals for vector functions, but here's one of them. We have the velocity, and we're interested in finding the position function. And of course, for that, we need a boundary condition. So the boundary is that at 0, r is at 0, 0, 0. So we're going to use those to find the constants. Okay, in order to do this, we're going to use the formula that rt, of course, is equal to the integral of vt dt. But we're going to do this 3 times, once for each piece. So we're going to find r of x, and that's going to be the integral of t dt. Of course, the integral of t dt is 1/2 t squared plus c. And then finally, applying our boundary condition at t equals 0, this equals 0, which means our c will be equal to 0. I'll actually call it c1 since I've got to do a couple more of these. Okay, r in the y direction is going to be equal to the integral of t squared dt. And of course, that's going to be 1/3 t cubed plus c2. And once again, at t equals 0, this is at the position 0, so c2 is also equal to 0. Finally, rz, that's going to be equal to the integral of cosine t dt. Of course, the integral of cosine is sine t plus c3. And at t equals 0, this is 0, that means c3 also equals 0. So our boundary conditions all turned out to be 0. That doesn't always have to be the case, but it was in this case. So here's our final r of t. The position of this function is given by 1/2 t squared, 1/3 t cubed, and sine of t. And this will generate all the positions for a function that has this velocity and starts at 0, 0, 0.